All right, for question 9, we have an infographic here that tells us the um, fulfillment and shipping, combined cost of Amazon, logistic costs is what they're calling them. And the headline of this article that we found this infographic in stated Amazon logistic costs increased 40-fold in 12 years. So part A, how did the author know to say 40-fold? Well, if you haven't heard the phrase 40-fold or twofold or threefold before, what that phrase means is essentially times as much. If you say that something increased threefold, you mean that it tripled. If it increases by tenfold, then it's 10 times as much now compared to what it used to be. So, how would the author have known to say that? Well, if we look at the data that's been given to us in this infographic, we know that in 2009, $3.76 billion were being spent on logistic costs. And in 2021, which happens to be exactly 12 years later, logistic costs had risen to 151.8 billion. Now, is that really 40-fold? Is that really 40 times as much? Well, we can find out by simply dividing those numbers against each other. So if we take 151.8 and divide it by that initial value of 3.76 billion, do we indeed get around 40 times as much? So 151.8 divided by 3.76 is 40.37. Okay, so is it exactly 40 times as much? No, but is there enough evidence to claim a 40-fold change or a 40-fold increase? Yeah, there definitely is. So 40.37 is telling us essentially how many times as much. So from 2009 to 2012, logistic costs, logistic costs were 40.37 times as much. And so that right there confirms that it is indeed a 40-fold. Now, what's the implied percent change for 40-fold? So if we use the change factor that we found, the 40.37, the question now is, what is the implied percent rate? What is that rate that is implied in a 40.37 change factor? So if we use our change factor, the 40.37, and we figure out that hidden rate, so to speak. Remember, the 1 is really just there to represent the 100% or the whole original value. The actual increase is what is left after that. So really, the actual increase is a 39.37 is the hidden rate, so to speak. Okay, but in this change factor formula, so to speak, that lowercase r stands for the percent rate in its decimal form. So 39.97 is not the percent rate, it's the decimal form of the percent rate. So to actually convert it to a percentage, we would times it by 100 or move the decimal 2 times to the right. Same idea. And we would actually get a 37% increase. So it is 40 times what it used to be, also known as a 3,937% increase. If we would have just used the 40, the flat 40, then it would have been a 3,900% increase. But I decided to use my answer from part A just for some accuracy. So either a 39%, or I'm sorry, 3,900% increase, or if we use our change factor from part a 3,937% increase, again, over those 12 years, right? So then for part C, what does that mean on a per 1 year basis? Okay, so if we have 40.37 as our 12-year change factor, and we now want to know what it does per 1 year, we just have to essentially exponentially undo those 12 years. So this is where our fractional exponents or roots come into play. So if you want to exponentially figure this out, you need 1/12 of that change factor. But again, it's an exponential 1/12 because you'd be multiplying whatever this value is. We don't know it yet. You'd be multiplying it 12 times in a row in order to get the 40.37. Well, how do you undo multiplication of 12 times in a row? That's where the 1/12 or the, well, I'm sorry, excuse me, 1/12 power or 12th root come into play. So to convert this to a 1-year change factor, we'll take our 40.37 and raise it to the 1/12. I'm just going to put a parenthesis around this, raise it to the 1/12. And it looks like our 1-year change factor is going to be 1 point, let's round it to 361. 1.361. 1.361. Okay, now this is the change factor. Okay, this tells us how many times as much the costs are next year. Just for fun, what does that mean on a percent rate basis? Well, if 1.361 is the change factor, then the actual percent increase is going to be that 0.361, also known as 36.1% increase each year. So the change factor tells us that next year they're going to be spending 1.361 times as much on costs, also known as an increase of 36.1% next year. And it just says, what does it mean? So we'd want to phrase it one of those two ways. It didn't specifically ask for one or the other. So I think as long as you understand both options, you could potentially be ready for anything in the future. Okay, part D, solve for when Amazon's logistic cost will be 200 billion. Okay, well, 200 billion, they're asking us to solve for an output value. If you look back at the data that we've been given, the inputs are, of course, the time in years, and then the output axis is the one that actually represents those billions of dollars. So 200 billion is a desired output on this function. Speaking of which, we haven't really built a function yet. So we're going to need to build one in order to answer part D. So the logistic costs as a function of time, I'll just kind of create these variables as I go. If I use 2009 as my initial value, then I could use the 3.76 as my initial value times a change factor of, well, let's use our per 1 year change factor since we have it now. So 1.361, and that is the per 1 year. So I can just do a power of T for time. Now, again, keep in mind, this is years since 2009. That'll be important later on when we solve this. So again, the desired value here is 200 billion, which is an output value. So we're going to position it on the outside of this equation to wrap our brain around what's being asked. So 200 is the output value, and my function, of course, is simply my function at this point. Now, how to solve for t? Well, notice t is in the exponent position, and we have not learned yet, keyword is yet, how to do that algebraically, what the inverse of an exponential function is. See, I can't just take a root right now because I don't even know what kind of root I would need. If the exponent was 3, okay, I would use a cubed root or a 1/3 power. If the exponent was 7, okay, I could use a 7th root or a 1/7 power. But I don't even know what the exponent is. So we haven't learned that yet, and that's why for this module, everything is asking you to essentially solve it in Desmos using what we call intersect method. So what you can do is, first of all, let's get a feel for what this function looks like. So my function was 3.76 as my initial value, and my change factor was 361? I'll confirm that in just a second. Okay. So this is essentially what Amazon logistic costs graph would look like. Let me confirm those values. 3.76 and 361. 361. Yes. Okay. So this is what Amazon's logistic costs are looking like. And we now want to know when they reach an output value of 200 billion. Well, I can see where that is on my graph. You know, I can like use my eyeballs right now to essentially say, okay, it's right there. And I just kind of want to touch it and be able to say, it's right there, it's right there. Okay, but how can Desmos, do this for us? Well, again, 200 is the desired output value. So in line 2, we use the letter Y for outputs. and we want to know when y equals, the output value equals 200. And you'll notice what that does, it just draws a horizontal line at the output value of 200. And we can now touch. Oh, look at that. It's going to take 12.89 years. 12.89. 12.89. Okay, so what does that mean though? So 12.89 is when the graph hits 200. But again, everything in this function is based on years since 2009. So it's 12.89 years after 2009. So if we think about that, what does 2.89 or 12.89 really mean? It's years after 2009. So it's essentially the end of the year 2021, right? Approximately 9 plus 12 is 21. So kind of towards the end. So we can say at the end of 2021, Amazon logistic costs will reach $200 billion. Billion. Don't forget the units of billion. Okay, there we go. All right, and last but not least, find the doubling time. Okay, so two ways you can do the doubling time on this one. I'll set it up both ways, but then I'll probably only solve it one of the ways. So since we do know the initial value of this function, again, using 2009 as our starting point, one option is to literally double that value to see just how long it takes for that initial amount to be doubled. So if you just ask yourself, well, what is 3.76 times 2? We'd be waiting patiently for the logistic costs to reach 7.52 billion. So one way to wrap your brain around this is you're looking for a desired output value of what did I say? 7.52, that's right. 7.52 billion. So 7.52 billion is the desired output value of this initial function using the initial value as 3.76 as shown in the graph. That is option one. The other way to do this that I think is really important because you don't always have the initial value. And so it's really important that you understand that option two does not need the initial value at all. And with option two, all you really have to ask yourself is how long does it take for your change factor, this 1 unit change factor right here, how long does it take for that change factor to amount to a 2, a doubling, a 2 times as much, so to speak, right? And the other thing you can think about is even if you were to go back to the original full equation, if you will, well, okay, the one little bit of algebra that we do have in our pocket is I could divide by 3.76. I really could. 3.76 is getting multiplied. So could I divide by that? Yeah, I could. But guys, what is 7.52 divided by 3.76? I'll give you a hint. It's 2. Because remember, where did we get 7.52 even from? It was from doubling the 3.76. So certainly if you divide by 3.76, you're just going to get 2. It all really boils down to this relationship right here. And option 2 is a really important relationship because again, sometimes you don't even have the initial value, and yet you're still expected to solve for double times. So I'm going to do it this way just because. So again, we haven't learned, I should say, how to undo an unknown exponent at this case. So our option is back into Desmos. And this time I'm just going to eliminate my initial value. And I'm just going to focus on the growth factor itself. And this time I want to know how long it takes for the growth factor to amount to doubling. Just a little 2 is what I want to intersect with. And it looks like it happens in 2.24. Let's round it to 2.25 years. So when you solve either one of these, by the way, if you were to solve this equation, you would get the exact same answer. You get 2.25, comma, 2 in my case. If you solved the other one, you would still get 2.25, but it would be 2.25 comma 7.52. So just kind of, the options on how you approach it. But what does this mean? So if the doubling time is 2.25 years, because remember, our input variable right now is time, right? The input variable is time. So what we've just found is that not just in 2.25 years will it, be doubled, but every 2.25 years it will double. In 2.25 years, costs will double. Another 2.25 years, costs will double again. So that's what your doubling time means. It means that Amazon logistic costs will double every 2.25 years. Now, again, technically after 2009. We don't know what happened before 2009. So all of this is based on that value. So, all right, there is question 9. Hopefully that was helpful. Thank you.